Hello everybody and welcome to this afternoon's webinar, recording and presenting findings. So today we're going to be talking about recording and presenting findings. So just to refer back to the skills and the inquiry types, we've got the 5 inquiry types which you can see around the outside there: classifying, fair tasting, pattern seeking, researching and observing over time. And this afternoon I'm going to be talking about those 2 parts that I've highlighted in red: the recording results and then presenting results. So again, just referring back to the national curriculum and using the plan working scientifically matrices, you can see that we've got a number of statements there from Key Stage 1, Lower Key Stage 2 and Upper Key Stage 2. And you'll notice that in Key Stage 1, it's more about gathering and recording, although we've included in there different forms of presentation such as pictograms and block graphs. As we go into Key Stage 2, there's more of a focus on the presentation side of things. And we've put both of those statements in Lower Key Stage 2 together because there's quite an overlap between those 2 statements. So as we go through this webinar, we'll be looking at the progression of those skills. So I'd like to start with creating tables. So in Key Stage 1, the children may well be given a table that they're going to be filling in. So we need to teach them how to fill in the table appropriately. And then as they move through, possibly into Year 2 if they're ready for it, or when they move into Year 3, we want them to start creating their own tables. So here we've got, there was an inquiry going on where the children were dropping 4 different balls from the same height, and they were measuring the height with a ruler. And there's different ways that the results have been recorded. What I would like you to do is have a look at those 4 different methods of recording and post on the chat, what do you think about those different methods? Thinking about, is it effective? Is it easy to gather the data? Is it easy to see the data and understand it quickly? Is it efficient? Is it easy to produce? Is it easy to record in that way, or is it going to be quite time consuming? So think about them in terms of effectiveness and efficiency. And if you just type the number and a comment, that would be great. Between you there, I think you've covered all the points that I would like to say about it. As has been referenced there, number 1 is too wordy. We don't need to spend all that amount of time writing. It's not a writing lesson, it's a science lesson. And we need to get away from this idea that writing lots is good and writing little is bad. When we're recording in science, we want it to be efficient and effective. Number 3 could be very time consuming. The children are spending more time drawing and colouring than they are actually thinking about the data that they've gathered. Number 2 is quite clear. It's laid out quite clearly. It's using less words, so that's good. But what we're losing here are those units. So we don't really know what these measurements are about. It could be the number of small blue balls we've got. It could be the size of those balls. We just don't know what it's telling us. And then 4 is quite effective and efficient, but as people have pointed out, the data has actually not been recorded properly, and that's what we're going to just go on and think about in a moment. You can see that the data is not lined up appropriately. So there's some key things that we need to remember, and we need to teach the children these skills. We need to teach them, once they've learned how to fill in a table, we need to teach them to construct their own table. And they need to be taught some key things. So first of all, assuming that they're starting with a piece of lined paper, we would need to model this process for them where they're drawing 2 lines, and that is basically the structure of their table. And then as I'm going through this, or afterwards at the end of drawing the whole table, I would ask the children to share with me what are going to be the success criteria for them to draw a complete table. So at this stage, they'd need to remember, and using a ruler for me is quite critical, they would use a ruler to draw the horizontal and vertical line. Then we need to add the headings to the table, and what goes in the first column is the thing that we are going to be changing. So in this instance, it was the ball that was being changed. So we need to put the heading of the thing we're changing. And then in the second column, we put the measurement or observation that we're making. So it's the variable that we're observing and measuring. And we also need to remember to include the units that we're using. And it's good practice to put the units within the heading rather than having to put them each time. So we add the units, and then we need to add our data, being really careful that the data associated with the small ball is actually on the correct line. So we need to put the data in, being careful that it's all on the lines. And I think that's why it's important that children do use lined paper. So we need to ensure the results line up properly. So if I now want to think about that, how that might look in different types of inquiry. So if we're doing some classifying, we're using classification to answer one of our questions, there are two ways that the children might have a table. So it might be the first option there, where they're writing down which materials they have got in the first column and then answering the question directly, does it stretch, yes or no? Or it might be that we have those two criteria, it's stretchy or it's not stretchy, and they put the name and the material in the right column. Another way of presenting that same type of classification would be with a sorting hoop. So here we've got a range of animals, and the criteria, it goes in the hoop if it's got wings, and then it will be left outside the hoop if it doesn't have wings. I like to use one hoop for this rather than having two separate hoops, wings and no wings, because it's good for the children to start to recognize that it's okay for the objects to sit outside the circle as well. And that's useful later on when they come on to further Venn diagrams. So I think in Key Stage 1 with something like this, the chances are that we're teaching them these different methods of presentation. So we're probably going to say, why don't you use this table today, or this type of table, or use the simple Venn diagram. Whereas hopefully by the time they get to lower Key Stage 2, they're now familiar with these types of presentation methods, and they'll be able to choose for themselves what they feel is mostly going to be most appropriate for them, or the way that they would like to do it for themselves. The other way that the classification will show progression as we move through the school is that they tend to start with just looking and focusing on one criterion, such as we had before, where it was it stretchy or not. Whereas as we go through into lower Key Stage 2 and then in upper Key Stage 2, we're looking at more criteria at once, so two criteria or multiple criteria. So for instance, if we're in Year 5 and we're doing some work around materials, we might ask the children to think about what properties does the material for a tent require. We'd probably start this first with just some sorting and grouping, where they're coming up with all the criteria, and then they'd think about which of those properties are important when it comes to a tent. For this example here, I've chosen flexible and waterproof as two properties that are important when we're choosing our material. And the children will then sort them. I've put the two hoops separately here, and that's what I would do in the classroom. I would put the two hoops on the table separately for them and ask them to label each hoop with the criteria that they think is important. And then the children will sort the materials, such as like that. You notice I've put metal as being flexible here because in the material they have in front of them is actually tin foil. Wood doesn't fit into either circle, and that's again, that was the one the children didn't like. If they had it on Word, they'd sit on it or get rid of it because they didn't like it sitting outside the two circles. And that's why in Key Stage 1 I give them one, so they're used to having words or objects outside the two circles. But what you're probably noticing there and thinking Naomi's gone mad is that metal and polythene are actually waterproof as well. But when children are doing this, they'll often pick up a material and put it in the right circle for themselves. And then a child will spot that somebody's put a material in the wrong place, and they'll sneakily move it from one hoop to the other. And then the child that first sorted it will move it back again. And so it may be that somebody moves the metal and the whatever the other one that's now hiding moves that over. And then eventually, when it's gone backwards and forwards a number of times, they realize that it needs to go in both circles, and then they actually cross them over and form that intersecting Venn diagram. And I think it's good for the children to go through that process of forming that intersecting Venn diagram for themselves, because they actually then really understand the structure of it, and they understand why we've got these 4 different elements of it. And then obviously, if we then want to choose our tent material, it's the ones that have got both. So it would be the metal and the polythene. We may want to look at more properties, and a Venn diagram, although you can add 3 or 4 circles to a Venn diagram, it starts to become quite tricky to actually read. The circles become very small, the spaces become small to put the data into. So a better way might be to look at and use a key. So here I've decided that it's important for it to be flexible. If it's not flexible, it can't be rolled up, so it's not really tent material at all. It then also needs to be waterproof and strong. Different groups may well put their criteria in different orders, and that's absolutely fine. But then we take each of those materials. So my metal, remember it was tin foil, was flexible, it was waterproof, but it's not strong. So it would end up there on the Venn diagram. The fabric is flexible, but this particular fabric, when they tested it, wasn't waterproof. The china is not flexible, glass not flexible. The wool was flexible, but not waterproof. Wood was not flexible, polystyrene not flexible, PVC not flexible, and then the polythene will come down. It is flexible, it is waterproof, and it is strong. So that would be a good choice of material because it meets all 3 of our criteria. If we don't have the polythene to hand, or for another reason we decide it's not appropriate, we would need to look at some of the other ones and decide maybe we can combine 2 of them to make a composite material that will do the job. So moving on to a different type of criteria, a different type of inquiry. So when they're doing pattern seeking, initially in Key Stage 1, we might ask them, we might send them out with a sheet which has got some images on it, and they'll be able to just tick as they find each of those animals, they can tick it off to say that they found it. So they're basically matching what they're seeing with the animals on the sheet, and that will help them to name and identify them. We may ask them to go out with a blank piece of paper to find out how they might record it. And here you can see what's happened is every time they've seen a worm or they've seen a spider, they've drawn a separate picture. So it's telling us not only what have you found, but it's telling us how many you found. But again, we're drawing quite time consuming, and also the data's scattered all over the place. So it's going to be quite difficult to count it up at the end. So here we've now moved into using a tally chart. So we could use the same sheet that prior they were ticking on, but this time we teach them how to do the tally chart. So they're putting the 4 and the crossbar across. So they could be doing that on the picture sheet, or we might start to encourage them to here we've got the basics of a table, although the lines, the horizontal and the vertical line, haven't been drawn in yet. So you can see that's how we would be progressing that child on next. We might encourage them, perhaps once they've named the animal, to not have to draw it anymore and to use the name in words instead. And then that would be them gathering the data, and then they may start to present it either as a simple pictogram like we've got here, although at this stage you can see again it's not necessarily fully structured, fully formed yet. We don't have any numbers up the side. It would be better if it was on squared paper. So there's ways that we can develop this further, or it might be that they use a bar chart. So here you can see this is taken from the plan resources. This was Max in year 2. And the first time he went out and did his mini beast survey, he was given the sheet. He was taught how to do the tally chart, and he was given the sheet to fill in. And then when he went out again later in the year, there was an expectation that he would do it for himself. And you can see that he's now constructed the tally chart for himself. He's got the headings there, and he's sort of started to divide it up with the lines. Don't like the fact he's not used a ruler, but you know, we'll let him off. With the presenting, the first time, again, he was given one to a pictogram to fill in, and he's drawing all the diagrams there, whereas he actually then went on, this is the same information presented as a bar chart as well. So he's actually presented that same type of data in 2 different ways. So we've talked about tables and different ways that you can gather data and support children to develop tables, and other types of presentation in classifying and pattern seeking. And I want to now move on to focus on presenting in graphs, and this is particularly to do with comparative fair testing and pattern seeking. And it's really crucial that the children start to recognise that the type of graph that they're choosing to use is actually depending on the data that they've got. It's not dependent on what type of graph they would like to do today, or whether they think a line graph is a bit too tricky for me, or a bar chart is too babyish for me. It depends on the type of data they've got. So if what you're changing is in words, so for instance, the ball that we're bouncing, we're changing the type of ball, and what we're measuring or observing is in words, so it bounced high, it bounced low, then actually you can't produce a graph at that point at all. Similarly, as soon as you don't have measurements, you basically can't produce a graph. So even though we're changing something in words, when perhaps dropping it from a different height, we still can't draw a graph because we haven't got any measurements. Once we get into something where we do have measurements, so here, for instance, we're changing the type of ball, so we're changing that, and we're now measuring in centimeters how high it is, then you would be drawing a bar chart. If you've got discrete numbers, I don't think it works with the bouncing balls, but if you've got if you were bouncing it onto a number of layers of sponge, for instance, you could have 1 layer of sponge, 1 PE mat, 2 PE mats, 3 PE mats. You can't have 3.5 PE mats. So we've got discrete numbers there, and we may be measuring the height again, but we would be forming a bar chart again because of those discrete numbers. Whereas if we're dropping the ball from different heights, so the variable we're changing is in numbers and we're measuring the height, we would then get a line graph. Or if we're changing things as part of a pattern seeking exercise and we've got the numbers, the two measurements in numbers, then we would produce a scatter graph. So what we're going to try and do now is, if you can go to your Mentimeter, so if you can put in www.menti.com and the code 235157. I would like you to, we're going to go through a number of different questions, and you will think about what type of presentation will be the most appropriate. Okay, if you're still putting your answer into the Mentimeter, that's absolutely fine. And it's interesting how we've got 2 different answers there. And actually, I don't think either of you are, and neither group is wrong, because it depends. I was very vague about how does the amount of sugar, if we're talking about a big amount, a small amount, or possibly 1 teaspoon. The problem is with 1 teaspoon, 2 teaspoons, although it is, we can have 1.5 teaspoons. So the chances are, I would say probably it is more likely to be a line graph, although I can't categorically say that you're wrong with the bar chart. But certainly if they're thinking about measuring it in weight, or if they're doing it as spoonfuls of teaspoonfuls, for instance, then actually it would be continuous numbers. So it would be a line graph. If they're just using a teaspoon, a dessert spoon, and a tablespoon, then it would be a bar chart. So how does the number of layers of bubble wrap affect how quickly a cup of tea cools to room temperature? Okay, thank you very much. And I'm in agreement. Oh, the last minute we had a sneaky line graph entered in. I'm going to just go with the bar chart anyway, with the vast majority of you there, because we've got layers of bubble wrap. It's difficult to get half a layer of bubble wrap. It's not going to be bubble wrap anymore. It's just going to be a one layer of plastic. So we've got discrete numbers there that we're changing, and we do have a measurement. So it would be a bar chart. Is there a link between birth weight and the gestation period of a mammal? If you just type it onto the chat, which one would you use? No graph, bar chart, or scatter graph? Okay, so is there a link between birth weight? So assuming that, well, what I was assuming, although people are now contradicting me on the Mentimeter, you might want to justify, because it may well be that you're thinking about it in a different way to me. So my thinking was that birth weight will be in numbers, probably in grams or kilograms, depending on the size of the animal. And the gestation period will also be a number of days, a number of months. So therefore, we've got two numbers, and we're looking for a pattern between the two. So this would actually, it is a pattern seeking exercise. So it would be most appropriate, I feel, as a scatter graph, because actually there may well be mammals that have the same gestation period but different birth weights. So actually it wouldn't be appropriate, although we've got that numbers and numbers, it wouldn't be appropriate to do it as a line graph. So it's quite important that we do help children to understand the differences between these types of presentation, so that as they go through the school, particularly when they get into year 6, they're able to do this independently, choose their own type of graphs. Let's move on to the next one. Okay, so how does the size of the parachute affect the path of its descent? Okay, thank you very much. We're all in agreement until somebody now suddenly pops something else on there. We're all in agreement that there's no graph, because what we're observing is that its path. So we're not measuring anything. We're just looking to see whether it falls straight down or whether it sways from side to side. I think I may have just a couple more. So how does the circumference of the ice balloon change each hour? Okay, so we've got a little bit of a difference there, but let's just think about it. So we're going to be taking the measurements every hour. So the thing that's changing is actually the time. And this is it's a little bit complicated. It's an observation over time. So we're changing the time. So we're measuring it after 1 hour, 2 hours, 3 hours. So that would be going across the bottom of our graph. And then we're measuring the circumference. And I'm assuming that we would get a tape measure out or a piece of string, and we would actually be measuring that in length. So my interpretation of that question would be a line graph presentation. How does the length of the spinner arm, and I popped a little picture there for you in case you've not done those paper spinners in class. So how does the length of the spinner arm affect the time it takes to fall? Okay, so again, we could justify either, because it depends on how the children are, what they're changing, how they're thinking about what they're changing. If they're saying it's long arm, short arm, then it would be a bar chart. If they're actually measuring the length of the arm in centimeters, then it would be a line graph. Okay, so we're going to move on. So once they've established what type of presentation method is the most appropriate, then if they are drawing some sort of graph, the next thing they need to think about is selecting the scale. And this is something that my children used to struggle with quite a lot, and they wouldn't necessarily think about it before they started writing the numbers on. So they tend to go 1, 2, 3, oh, I'm going to need some higher numbers, 5, 10, oh, I'm not getting enough, I go 10, 20, 50, 100. And the problem is with that, obviously, the numbers are not being spaced out equally along the graph. So one thing you can use is a scale selector. So this is one from a book called Getting to Grips with Graphs. I was trying to find one on the internet. I can't find one that you can actually buy, but you can just make your own. So the scale selector, the size of the scale matches with the line graph, the squares on the line graph, and you can cut it up into separate sections, as you can see here. And then what you can do is actually join them together with a split pin and to form a little fan. And the way that it works is that the children then place the scale selector next to the line, next to the axes, and you can see there that if I use that scale on that bar chart, on that graph, I can't make the lines any longer. So the highest value that I can record on there is 700. Because of the shape of my paper, the highest number, if I chose scale DG, the highest number I would be able to record would be 8. So what the children need to do is actually look at the data that they've got in front of them. So here we've got some data from an investigation where they're rolling a truck down a ramp and seeing how far it goes. So have a quick look at the data in that and think about what goes across the x-axis is the thing that you're changing, and this is standard for whatever graph you're drawing. And then what goes on the y-axis is what you are measuring. So just have a quick look at the scale selector and decide which scale do you think you would use on the x-axis and the y-axis. And if you just type x equals scale whatever onto the chat. Okay, this is actually really difficult for you doing it on screen because you can't physically move the scale selector. So now that you've had a little bit of time to have a look, I'll actually just show you how it would work in practice. So if I choose, if you see here, if I choose scale D, the numbers that I'm able to put on go up to 700, so therefore 400 will fit. It's not great because it's going to be quite a scrunched up graph, but it's the best option that is available for me with those particular scale selectors. And then up the side, I would be using scale A. So on the y-axis, I would be using scale A because that will now go up to 40. I'm just checking that I've got this right. I need to go up to 34 and I've only got those 4 large squares. That's the thing, I can't make the graph paper any bigger. So that's why I would have to use those 2 particular scales. Let's just look at another one. I'm just going to go through this one for you because I'm aware of the time going past quite quickly. So again, what we need to think about is what we're changing. That would be the minutes, the time. So across the bottom, we need it to go up to 50. So therefore, I would need to choose scale A. It does go up to 70, so it will only be, the graph will actually be stopping here at 50, but that's the only way I can get the data on. And then up the side, I need it to go up to 24. And again, I would need to use scale A. Although the graph will stop down here, it does all fit on. If I choose any of the other scales, it will start to go off my paper. So that's just one way of helping children to select the right scale before they're ready to choose their scale by thinking about counting up in multiple numbers. Nice bit of maths in there as well. The other thing that you can do is make human bar charts. And so here we've got some data and you have one child that stands up and you put, and I quite like to use post-it notes with those, the scale on it. So the children add the post-it notes to the scale. And then another child or 4 children can hold the what's being changed across the bottom there. And then a further 4 children, they stand at the appropriate height to be the bars of the chart. So you can see 49 is standing almost level with the 50, 37 is lower, 80, and then that last person is scooched down so we can't see them. Another way that you can then do this into a line graph is having one person standing up and labeled, and you've got the axis and also the headings on there. You've got the scale and the headings, and the other person lying down with the labels on them. And then the children can be added in and their fists are marking the points. And then you can pop a skipping rope between their fists and that will then add in a line. So it works well where you want to have that continuous line of joining the dots. The skipping rope will not work if you're trying to sort of draw more of a best line fit. If children are doing observations over time, this should be a line graph as we discussed earlier, but some children, you may well generate data in year 3 and year 4 that should be presented as a line graph, but actually they haven't learned how to draw line graphs. So it might be that you do a sort of stick and dot. So rather than having to do plot both points on the X and the Y simultaneously, they can actually just work from the X axis up and plot the point when they get to the relevant height. And then you can see that you're still seeing the same shape of graph, whereas in year 5 and year 6, hopefully they can draw the line graph itself. Using ICT can also help with this, particularly with scatter graphs or where you've got lots of data. So you can see here we just were measuring the size of people's hands by them putting them onto a grid and counting the squares that they covered, and then seeing how many sweets that they could grab. And you can see that you've got lots of data there, and using a spreadsheet or some too simple software, something like that, it can very quickly produce that line, that scatter graph for you without you having to do all the plotting. So that's really useful. What you can see here is data generated in exactly the same way around seeing if there's a link between resting heart rate and exercise heart rate. And what you can see that there is this general, you've got this cluster where most of the points are, and you can see that there is an increasing pattern. There is a pattern there. We do have one result here, which seems to be a little bit of an outlier. So we might want to just think about that data. But it might be that that particular person is just slightly different. There is a variation between us all. But then we do have these two sets of data out here, which are just so far off that we probably think there might be something wrong with those, and maybe we'd need to ask those children to measure again. The very last bit that I'd like to talk to you about is this statement here: children are supported to present the same data in different ways in order to help with answering questions. And you can see that the same statement is there in the year 5 and year 6, but they're not supported, they're doing it independently. And this is just, I'm just going to give you one example of this. So you can see here that Max was doing a range of different types of exercise and actually gathering quite a lot of different data. So he's thinking about how many times could he do that particular thing in a minute, and then what part of his body was he exercising and how did he feel afterwards. And then he's looked at all that data and re-presented it in a different way to show what he felt was the hardest to the easiest exercise. So he's presented that data in a different way to answer his particular question. So that's the end of what I'm going to share with you today. If you would like the slides, please do feel free to contact us on that email address there, and we will send you the slides. We will also put it onto YouTube, so if you have got anybody else that you think this would be useful for, do please share it with them. Next week's not after half term. I keep not changing these slides properly. Next week, the session will be about asking questions and planning inquiry. Thank you very much, and goodbye.